Let's talk a little bit about solid angles. First, let's just talk about circles here and the radian. So if I've got a circle, circles have a radius. If I take that length right there and I sort of have a piece of string and I wrap that around the edge, I can go a certain amount of distance, and that angle that is created there, so that the arc length is equal to the radius, that angle is 1 radian. And so therefore, if I had 2 radii, then the angle would be 2 radians and so forth. And ultimately, if I just take whatever the arc length is divided by the number of radii, that tells me the number of radians, so the angle in radians. Notice that arc length and radius are both units of length, and so they potentially have the exact same units, and so notice that the units would cancel out. So if I have a circle with a radius of 4 meters and an arc length of 6 meters, so that's my radius, then the angle in radians would be 6 meters divided by 4 meters, or 1.5. Well, the meters cancel out, so there are no units there, and that's a radian. So I will sometimes refer to radians as a unitless unit because you take it out or put it in whenever it feels convenient. So if I think about an entire circle here, how many radiuses can I wrap around a circle, around the circumference? Well, I can get 2 pi radiuses around. So if I have an arc length of 2 pi radiuses divided by the radius, I end up with 2 pi radians. So there are 2 pi radians around an entire circle. So now let's talk about a sphere. I have a center, and basically I am mapping out a little section right here. So if I have a radius of a sphere and I look at a patch right here that is radius by radius, basically a square, 1 radius squared. So that's the area of the surface right here, not drawn to scale. Well, I can come up with an idea of how many steradians are an entire sphere, because the surface area of a sphere is 4 pi r squared. And so therefore, since a 1 steradian, so this angle right here is a steradian, abbreviated as 1 SR, then using similar logic over there, that the surface area divided by the radius squared is equal to the angle in steradians. Well, if I look at an entire sphere, I get 4 pi r squared over r squared. In other words, an entire sphere has 4 pi steradians. This is for entire sphere, traditionally written with an E at the end.